Hey seniors, welcome to video 2.8.1, where I'm going to try to segue you between the more basic derivative rules you've been learning and the more complicated rules that are to come. So real quick, I'm going to recap just some of the rules you learned in the last few objectives on this video pretty quickly. So if I have this polynomial a of x equals this value, like I said, it's a polynomial, so I get to use just the power rule with each term. The 2 would come down. 2 times negative 1/2 would just be -1. And then the exponent there would just be 1. So I can leave it as negative x. Negative 5x derives to be just -5. Then a constant goes away. And my notations of it should be a little apostrophe for prime. And so a prime of x would just be negative x minus 5. So the derivative would just be slope of -1 and then y to the -5. Right here we have b of x, which at first looks kind of tough to derive, but reminder, I can rewrite this as -3 and then x raised to the negative first power. And now I get to just use the regular power rule. So the -1 comes down. So I have b prime of x is equal to a +3 and then x minus, if I take 1 away from -1, I actually have -2. And then in general, you'll oftentimes see expressions simplified to have all positive exponents. So we would write b prime is equal to 3 divided by x squared. Now over here we have c of x, where we learned both these derivatives in previous videos, but I know the derivative of cosine is a negative sign. I always think in my head, I like sine, I don't like cosine, so cosine derives to be a negative value. It's not a real way to remember it, it's just how I do. And then I like sine, and that derives just to be a positive cosine. So what I would oftentimes do, and what you'll see done is, for some reason we put the positive term first. What we already have is totally fine. But if you wanted to rewrite it with the sine term subtracting, you could easily do that. So now for this one, you might first be thinking, like, how do I derive this? But what's cool is, if we ever can work to simplify an expression, we should try to do that first. And what I can do is write this as y is equal to, I'm dividing both the terms in the numerator by x. I can actually write those as two separate fractions. So 2x divided by x, and then minus, that's supposed to be a minus sign, minus 4 divided by x. And now if I simplify both of those, I can write the y function as just 2 minus 4 divided by x. And so now I can say dy dx. I could say y prime as well is equal to, well, the 2 just becomes 0. And then I can kind of repeat the same process from the previous step. There's a better place to write this for sure. So I'm kind of showing two steps at once, but right here I can just write this as -4, then x to the negative first power. So -1 times -4 is a +4, then x to the negative second. And again, I'll show, like last time, you would see this more often written as 4 divided by x squared. I'm going to change colors because I'm tired of writing in blue. So let's use a complementary color. F prime of x. This is nice. We know the derivative of the natural log is just 1 over x. So this would be 2. And then if I should probably do it in 2. This would be 2 times 1 over x, which is just 2 divided by x in the end. And again, a coefficient with our derivative rules, we can move that in front of the derivative function. So I actually could have written this as 2 and then dx of the natural log of x. So it'll be 2 times 1 over x, and that's how it ends up at 2 divided by x. And then this is nice. We know that e to the x derives just to be itself, so nice and easy. And so now this brings us to this point where I have this function p of x, which looks different in the ones we've been deriving. And you're right, it is different because this is showing a product. And we don't know how to derive this one yet. And this is objective 2.8 you're seeing right here, is how do we find the derivative of functions that have a product built in? And I know this, so I know this is going to end up being, well, the derivative of the first function, which is just 4, and then times the other function as is, and then plus, and then I should have written with better space. All right, so I wrote it out below, but I know how to use the product rule. You're going to learn about it next, but I know that the derivative of the p of x function would be the derivative of just the first function times the other original function, and then plus the original other function. And then we kind of get to use the power rule. The 2 comes down, and then just times x minus 2. And so what I have right here is actually the derivative of p of x. And to be clear, this is the same thing we've been doing. This much more complicated expression, it still just helps us describe the slope at any given point on the original p of x function. I'm going to go to 7, and 7 is showing off, again, a different function we don't yet know how to derive. It's showing off a quotient. Now, I hope you're thinking, like, hey, can I just factor that and cancel? Really close. We should always look to simplify. But if I actually factor out a 2, I still just have this rational function. And so I can't, at this point, do any more simplifying. And to find this derivative, I need to use the quotient rule. Quotient, again, just meaning dividing. We have a function that is dividing in some way. That's a quotient. And so that's what you're going to get into in these next objectives, is how do we find the derivatives of more complicated functions, functions that are not just polynomials and not just one or two term trigonometric functions. So let me scroll down. So here's one big takeaway I want you to have, which is different function types require different derivative rules. And then this ties into my advice, which is your first step in trying to find the derivative of any upcoming function is understand the math language you're reading. Like, read through it and say, is it a polynomial? Is it just a function adding and subtracting terms? If so, we can use our power rule. Is it a function that's multiplying? Because if so, we need to use a product rule. Am I seeing a division? Am I seeing a quotient? If so, I got to use quotient rule. And so these are the upcoming derivatives. And again, right here, product rule is 2.8, quotient rule is 2.9. You'll get into some of these trig derivatives in 2.10. You actually have a pretty good grasp, hopefully, on the stuff you're seeing in 3. But again, notice how even in these, we're actually showing a combination of rules. So we know how to derive that term. But right here, we're seeing natural log and a product. So we'd have to use product rule with our previous derivative rule. So it can get complicated. And then this will be unit 3 right here. We're going to learn how to derive inverse functions. So like if I had y is equal to arc sine of x, what's the derivative of that function, which is pretty cool. And then chain rule actually gets into, well, what if I had, for example, sine of 3x? And yeah, the derivative is not just cosine of 3x. Like, how do we actually derive functions within functions? We're going to use the chain rule. So this is a little preview of the derivatives that are up and coming. And last piece of advice I have for this video is verify your derivative expressions by analyzing the function. I'm actually going to do this next, where I show off that the derivative I found up here, this p prime of x, actually does describe the slope of p of x. But that's my advice initially is, use graphs, use Desmos to verify that you actually did find a correct derivative expression, especially as these can get kind of complicated. So now I think I hit all my key points. You're on to the go formative questions to see if I can just not analyze, but I can identify just what the function, what's happening within a function. Can I see a product when it's there? Can I see a quotient clearly? So that's going to be the rest of this objective. And then you're actually going to get onto the product rule, the quotient rule, and upcoming objectives. Hope it made sense. I'm here for you all. Let me know what your questions are.